So the first question is easy enough. We don't really need the GDC too much to do this, just apart from a basic calculation. The expected number of brown eggs in the box, well, that's simply the number of eggs that we have in total, so the n value multiplied by the probability of having a brown egg. If we multiply those two things together, we'll figure out the expected number of eggs that we get, so n times by p, which in this case is going to be equal to 12. The next question, find the probability that there are 15 brown eggs in the box. So first of all, we should set up the right notation. The probability that x is equal to 15 is what we should write down. And we should also have stated that this is a binomial distribution. So x is distributed by the binomial distribution with n trials, so 240, comma, probability of success, so 0.05. That will then inform the examiner that we've recognised its binomial distribution for an easy method mark. So how do we then do that on the GDC? Find the probability that there are 15 brown eggs in the box. We go on to a calculator mode, and we go into menu, probability, and distributions. And the distribution for binomial is quite a long way down, so we have to scroll down onto the next bit. And we've got these two here, binomial PDF, binomial CDF. So PDF is the probability distribution function, CDF is the cumulative distribution function, i.e. it's going to add several probabilities together. So for this one, we just want to know one individual probability, so we'll go for this one, D. And it gives us all the information that we need. We've got 240 eggs. The probability of success, the probability of seeing an egg that a brown egg amongst these is 0.05, so we just type that in, and then we can either give it the x value, so in this case we can say the question is asking us what's the probability of finding 15 brown eggs. So we can just type in 15. If we left that blank, it would give us the probabilities for every single x value. So it would give us the probability for x being 0, 1, 2, 3, 4, 5. The problem with this question is that that's going to go right up to x being equal to 240. So that would be a huge long list of probabilities. So it's definitely better for us to be able to just type in that one individual x value that we're looking for. Click OK, and it's calculated it for us. So we would then write this down, rounding it to 3 significant figures, so 0.0733, because we're rounding that digit up. The next part of this question is saying, find the probability that there are at least 10 brown eggs in the box. So first of all, I'd write that down using the probability notation, i.e. P bracket x is greater than or equal to 10. So at least 10 means 10 or more, greater than or equal to 10. And we can then do that again on our GDC. If we go back onto here, we'll go menu, probability, distributions, but this time round we're wanting to work out several probabilities added together. We want to know 10 or more, so we basically want to be adding together the probability that x is equal to 10, added to 11, added to 12, 13, 14, all the way up to 240. So lots of probabilities to add together there. So we'll put the information in. We've got 240, 0.05, the lower bound, so we're saying for this one 10 eggs or more, at least 10 brown eggs. So that means the lower bound here is going to be 10, and the upper bound, the most eggs we could get, well, if we're saying 10 or more, then the most we could get is 240, so we could have all of them being brown eggs. So if we then click OK, it will add all of those probabilities together and straight away give us our answer of 0.764 to 3 significant figures.